Hello everyone, welcome to your first actual lesson for algebra in this second semester, this new year, 2021. We're starting off with systems of equations. All of last semester we were talking about how do you make an equation from a line, how do you take 2 points and make an equation, how do you graph an equation. Well, here we have a system of equations. So let's just start off by saying this is going to be pretty easy to start off with, and it doesn't get difficult, but the number of steps in about a week, the number of steps it'll take to solve one, it'll be about like 6 steps or something like that. But it's not hard, it's just more steps. Because a system is 2 or more equations, and every equation has a graph. Go ahead and write this down. A system is 2 or more equations, and every equation can be graphed. So here's an example. Just go ahead and make a quick axis, label it X and Y, draw 2 lines on it, like the ones that were shown. I'll erase what I did so that you can just see the original clear one. We got 2 equations here because we have 2 lines shown. A solution between a system of equations is whenever these lines intersect. A solution is whenever these lines intersect. Make sure you write that down. And where that builds, go ahead and label on that graph that you drew before, 1, 1 is the intersection. That's 1 for X, 1 for Y, was the intersection between these 2 lines. Since that intersection can be written as an ordered pair, that means that if you take that ordered pair and you wrote it into the equation for those lines, if you plug that number 1 and 1, if you put 1 for X and 1 for Y, you should get the same answer because the 2 lines intersected. Pass out the notes, but we're virtual, so no passing out anything. Let's just go ahead and copy this down. Just a second ago, I gave you like an informal definition for a system of equations. A system of equations, in a more math way of saying it, is a set of equations. An example could be y equals 3x plus 5 and y equals negative x plus 5. That's just 2 equations, and if there's more than one of them, we can call that a set. A solution to the system is the point where they intersect. Make sure you're writing this down. And I'm going to go ahead to the next slide. Whenever you're graphing equations, and whenever you just have equations that exist, there are 3 ways you can describe the answer to that system of equations. Either there is one solution because they intersect once, or there is no solution. And if there's no solution, that means that they have the same slope, but different y-intercepts. Same slope, but different y-intercepts. And in the last one, we have this one that looks like it just has 1 line, but really it has 2 lines that are on top of each other. And this would be called infinite solutions. If you're just one thing on top of the other thing, you're always going to be together, and so you will always have the same equation. For example, y equals 3x and y equals 6x minus 3x. This second one, 6x minus 3x, is 3x. So these are really the same thing, So if you plug in numbers into one of them for x, you're going to get the same answer for the other one for y whenever you plug in for x. I didn't say it, but the only way that this slide is going to make sense is if you draw these 3 graphs into your journal. They don't need to be huge. They should just be large enough so that you can identify the difference between... Now that was terrible. You need to make your line straight. The difference between the axis and the intersection point, and go ahead and put a line at the intersection or the solution. Go ahead and draw your 2 parallel lines on the x and y axis. There are 3 ways that you could solve a system of equations. The way that we're showing you today is graphing. The way that we will do next is by substituting. And we've kind of already done that way. And the final way is eliminating. Graphing is the easiest way, especially if you have a graphing calculator. Substituting is the most common way. For somebody who's actually solving a problem. Or a scientist. You're going to take an answer that you got in one place, you're going to plug it in somewhere else, or sometimes you won't even have the answer. You just take the whole equation and you plug it into a different equation. That'll give you something that you can plug into the next equation. And so you just keep on taking your variables, substituting them into the next place until things work out. The final way is eliminating or elimination. This way is only done in math. It works efficiently. But is abstract. And what abstract means is it you can do it, but to understand the fullness of it takes thinking. Abstract is something that, like, you can see it just fine, and you can maybe even do it, but to really understand it takes a higher level of thinking.